Unlock the secrets of Six Sigma in just 2 minutes with this video. Instead of getting bogged down by complex formulas and theories, I will break down the big picture of Six Sigma and explain it in a simple, easy to understand manner. Impress your colleagues, management, and potential employers by confidently describing Six Sigma like an expert without needing years of training. Watch now to become a Six Sigma Masters. In order to understand Six Sigma, we will need to look at manufacturing process, what is variation and the source of variations in the subsequent slides. All man-made products that we use every day, from the simplest products such as toothbrush to a sophisticated high-technology products such as computer, will go through many manufacturing process in multiple factories. A manufacturing process consists of a series of actions which transform process inputs into a process output. A typical manufacturing process inputs are man, machine, methods, materials, measures, and environment. In this example of a toothbrush, the key process input will be the man that work in a company or the operators that make the product. The machine will be the molding machines that is used for material transformation. And also the methods will be the work instruction, and the materials are those polymer pellets from a reliable source of an approved vendor. Measurement process is to measure the key parameters of a toothbrush, maybe the toothbrush dimension such as length or width, and is able to give accurate data on the key parameters. Environment will be those products that are sensitive to environment factor that needs to be controlled. If you find this video informative, please give it a thumbs up and consider subscribing to my channel for more valuable insights and updates in manufacturing, supplier quality hacks to achieve consistently good quality products. By subscribing, you will be the first to know when I post new content. Let's look at what is variation. Let's say one of the key parameters that we would like to monitor is the toothbrush handle width. So what we do is that we sample 50 toothbrush from different time during the manufacturing process and measure the width using a vernier caliper. Then the data is collected against time and the width. Those data is being plotted into a chart where the y-axis is the toothbrush width and the x-axis is the time. And we can see that as time goes by, the process is not very stable. It's like up and down. And when we compare it into a distribution chart such as this, where these two lines represents the upper and lower specs limit which the customers want, you can see that some of this measurement is already over the specs. Variations is actually represented by a component called standard deviation, or here to make it simple, a sigma. So a smaller sigma is always wanted, means that the process is stable and you want the measurement to be as close as possible to the desired target. Therefore, smaller sigma, the better the process. This is what we call process variation. Let's look at what are the source of the variation. The source of variations is actually from the process input itself. So it could be from the man, where different operators could have different ways of setting up the machine parameters. It could be the molding machines where there is different molding machine that is used, or even the mold itself, or even if you use the same machine, sometimes the machine performance could have deteriorated if it's not well maintained, and it could be from the different batch, different types of plastic pellets materials from different suppliers. So these are all the source of variations which contributes to a variations in a process outputs. Unlock all of my courses on Udemy for only $12.99. If you are using a mobile device, simply tap on More to review the special rate course link. Click on the link to view over 15 courses in multiple quality areas offered. For desktop user, you can scroll down and click on the link to download the course list. You can then click in the list to get the special offer rate. Explore the ultimate Six Sigma Yellow Belt and Lean Mastery, which unlock manufacturing process efficiency. The transformative online course at Udemy, which equips you with the two most sought after skills in manufacturing in just 5 hours. Scan the QR code or click the link below to get this course for USD $12.99 using my coupon rate and become the expert in both Six Sigma and Lean. In our example of those 50 toothbrush handle width measurement against time, we found that the width is actually very unstable, means that it's up and down, and shows that there could be high variation in process inputs, which has contributed to the variations in the process outputs, such as in this case. And even some could be out of spec as well. The desired output width should be the customer specs. Therefore, at the end of the day, we wanted the process to behave this way where there is very little variations. How should we do this? In order to bridge this gap, we have to use a systematic approach, which is called Six Sigma, consists of step-by-step phase of define, measure, analyze, improve, control, and also report. So in define phase is that we will need to define the problem, understand the problem, stakeholder, and also the process management plan. In the measure stage, we will need to establish what are the key parameters to measure and establish the measuring process to understand the current performances, such as in this case, this is the current performances. And in analyze, we will need to understand what are the factor or the source of root causes that causes the parameters of the width of the toothbrush handle to behave in this way. Normally, we will use like cause and effect diagram of 5 whys. And finally, in the improve phase, what are the action plans that could get from this type of process or this type of output to this type of output with less variations. And finally, once we have established the action plans and it work, we should standardize the action plan into the process control plan and work instruction, and also monitor for sustainability. This is the meaning of reducing variations in Six Sigma. We would like to also understand a bit that why is it termed as Six Sigma. Let's look at those process with different sigmas. Like 1 sigma, we will have about 69% of reject with only 31% yield rate. That means you are producing parts that will be out of customer's specification. What is below this line is actually not wanted. That means these are all rejects. And if in 2 sigma, you will have a process with a reject rate of 30%, 70% yield. That means you have 70% of good parts, which is within the specs. And then in 3 sigma, which is the yellow line here, we will have 93.3% yield and only 0.6% of yield loss. There will be less parts that will be outside of the specifications. And in 5 sigma process, we will have 99.98% yield and also almost very negligible reject rate. And lastly, 6 sigma, the king of all, we will have almost nothing that is out of specification. That means it's only about 3.4 ppm reject rate, which is 99.99997% of the parts which can use. This is good because we want parts or yield rate as high as possible, means that the process will produce all good products, and this will also minimize the cost of operation. This is why most of the Six Sigma projects is always tied to the cost. Most of the people are lost because there's so many PhD, permanent head damage statistic tools that involve in Six Sigma methodology. Those statistics are actually here for a reason, are used for a reason, because in Six Sigma, only samples are collected for measurement in most of the time, especially in high volume manufacturing environment. And from the sample, we will also need to know that the behavior of the sample doesn't correlate to the population itself. Even though you can measure 100% of the present population, but you will not be able to measure the future population. This is where influential statistic comes in to give a certain levels of confidence that population will behave per the samples. Therefore, numbers and data are very important in Six Sigma approach. Variation exists in all process. Variation costs money, as you could have a lot of rejects in this area. Monitoring and controlling variations are the key to success in a manufacturing process. Six Sigma will help you to reduce variations from here to a desired process of less variations in here through its step-by-step approach from define phase of understanding the problem and also the process map, measure, establishing the metrics, the key parameters to measure and measuring the current or the baseline performances, analyzing of by determining what are the root cause that could have caused those variations, improve of determining the solution, and also some risk analysis performed, and control to standardize all those solutions in a documentation form such as process control plan to ensure that it's followed through, and finally demonstrate sustainability and also stability that is here. You could share this Six Sigma initiative with others, and I hope that I have made Six Sigma from a big picture perspective and make it to be very simple to understand. I hope you found today's video helpful in gaining a better understanding of manufacturing, supplier, and quality engineering. I love to hear your thoughts on what topics you like me to cover. So feel free to share your comments below. If you find this video valuable, please share it with others who might benefit from it too. Thank you for watching, and I can't wait to bring you a more insightful content in my future videos.